11.0 continued, equations of circles. A circle has all points equidistant from a given point. So on this example, here's my center, and then each of these points is equal distance from that point. That equal distance creates a center. So that's the point that is equidistant from all points on a circle. We're going to write it as h comma k. And then any segment that is the endpoint, that has the endpoints from the center to a point on the circle, that's a radius. So in this case, a radius would be the length from hk to xy. And then any segment whose endpoints are on the circle and it passes through the center, that creates the diameter. And the diameter is twice the size of a radius. So these are related to each other by double or half, depending on which one you're working with. You would double a radius to get a diameter, and you would half a diameter to get a radius. So how do we write the equation of this circle? So it all has to do with things being equidistant. And in particular, the radius, I would say, is the most important part because that develops this equal distant all the way around the circle. So if we wanted to know this distance to create this radius, because that's the element that actually creates the circle, recall that the distance formula is this formula. Now, if we substitute the distance between x, y, and hk into there, we would put the h and the k in for our y2, y1. So we've got x minus h, y minus k. And then the difference is what we're actually calculating. The distance is the radius. So now we've got this r in there. And then if we want this equation in terms of r without the square root, very often we will cancel that square root with a square on both sides. And finally, the way that you'll see the equation for a circle written is like this. R squared equals x minus h squared plus y minus k squared, where r is the radius and h comma k is the center. And notice that in the center, the h is positive, but in the formula it's negative. So that means that whatever kind of number is here, so if for example, if it said x minus 3, then the center would be a positive 3. So whatever this sign is, it's opposite of that for actually writing out the center. All right, and then circles that we'll see really often are circles that come from the origin, so coming from the 0, 0 point. So the cool part about that is that you would put 0 in for h and k, so you would have r squared equals x minus 0 squared plus y minus 0 squared. So that means that this 0 part goes away and you're left with r squared equals x squared plus y squared. And you can see that that represents the Pythagorean theorem from your x distance and your y distance from the center. So this is only from 0, 0. That's the equation only from the 0, 0 point. Other equations can be from different centers, and you would use this equation to use it from a different center. So let's try an example. Write the equation of a circle with the center 5, 2 and a radius of 3, then graph it on the coordinate plane given. So again, remember that this h comma k, when it goes into the formula, the subtraction comes along for the ride, and this is my r. So we've got our r squared, so 3 squared equals x minus h, so x minus 5, plus y minus k, y minus 2 squared. And then very often, we like to write it in the other direction, so we like to write it as x minus 5 squared plus y minus 2 squared, and then you can actually calculate that exponent there, so it equals 9. So this is the polite way to write the equation of this circle. And then we can plot it by putting our center. So 1, 2, 3, 4, 5, 2. And then you have a radius of 3. So the best way to put your radius on is to do it in the horizontal direction in both ways, and then do it in your, this would be the horizontal and your vertical. So 3 from the center in the horizontal and 3 from the center in the vertical. And then you can connect it to your best ability, connect it up to make a circle. Sometimes it still doesn't look too good if you don't curve it, but that's the best. If you want another point, so for example, it looks like it's going through a pretty nice point over here or even over here. If you wanted that, you can plug in a value. So say we wanted to know what was happening at x equals 3. We would plug in 3 here for x and solve this equation for y. You would be ending up calculating this, subtracting it from 9, and then taking the square root and adding 2. So it would be a process, but you can do it by hand to calculate other coordinate points. These ones are the major coordinate points that we're interested in, the center, and each of the vertical and horizontal radiuses or radii. Let's try some more examples. Write an equation of a circle with diameter whose endpoints is a 1, 1 and b 3, 5. This has a typo. This a was supposed to be 1, -1. Let's use a negative. In this case, it'll make the problem just slightly more interesting. You could do it with 1, 1. That would be fine. But let's make it a 1, -1 just to make it a little bit more interesting. So again, we're going to try to write write the equation of a circle with a diameter whose endpoints are a, b. So if we make a sketch of this, let's just kind of make a sketch. We really only need the first quadrant going on. So we've got a 1, -1, and then we've got a 3, 1, 2, 3, 4, 5, 3, 5. So what is this segment again? This segment is the diameter. So if I kind of try my best to sketch, ooh, bad sketch, it's more oval, sorry. But if I'm trying to sketch this, that length right there is the diameter from -1 to 3, 5. What I do know is that these two segments are congruent. So this is A, B, they're the same length, they're a radius. And then I know that this is the middle. So I'm gonna call it M. Because mathematically, we need the center and we need the radius in order to write an equation. So those are the two pieces we need. So to get the center, we need to find the middle between A and B. The middle of a diameter is a center. So we're going to find the midpoint of AB, which is the average of the x's and the average of the y's. So 1 plus 3 over 2, 1 plus 3 over 2. And -1 plus 5 over 2. So 1 plus 3 is 4, 4 over 2 is 2, and 5 plus 1, 5 minus 1 is 4, 4 over 2 is 2. So that means that this center is at 2, 2, which it actually does. My sketch is not that bad in terms of where that landed. You could use a real piece of graph paper to help you on this, but that middle is at 2, 2. Now, the last thing we need to know is what is the length of the radius? What is the radius? So we either need to know how long is it from M to B, or we need to know how long it is from M to A. It doesn't matter which one you choose, so I'm going to go ahead and find the distance between A and M. So the distance of AM. So then A is 1, -1, and M is 2, 2. So I'm going to use the 2, 2, so we're going to do the 2. Let's do the, it doesn't really matter. So if you do the 2 plus 1 squared, because that's the -1, and then 2 minus 1 squared. So then we get the square root of 3 squared plus 1 squared. So 9 plus 1, which is the square root of 10. So this is our radius. And this was our center. And now we're ready to write our equation. So we've got x minus 2 squared. So this is our h and this is our k. So x minus h squared plus y minus k squared equals, and I'm going to put it in parentheses, the square root of 10 squared. Now what happens with a square root in a square? Those cancel and we're left with x minus 2 squared plus y minus 2 squared equals positive 10. All right, give the center and the radius of the circle with this equation. So we're working backwards. So our h comma k is going to be our center. So again, you do the opposite of what comes with the equation. So our center is going to be at -4, because that's x minus h. And then this one is opposite of negative, so it would be positive 8. So our center is at -4, positive 8. And then our radius right here is inside of 48, because 48 actually represents r squared. So if we work backwards, r squared equals 48, the square root. So r equals the square root of 48. And then you can write that politely. That reduces to a 16 times 3. So that would be a 4 root 3 is a polite way to write that. All right, last one. Give the center and the radius of the circle with the equation. So this is not in the form that we like. And what I notice is that there are 2 x's and 2 y's. But if we want it in the form that we're familiar with, it's going to be a binomial squared plus another binomial squared equals a constant. So we need to manipulate this equation in order to get it as a binomial squared plus a binomial squared equals a constant. And the way we're going to do that is by completing the square. Recall that the special value that helps you complete the square is b over 2 squared. And we're going to be doing it 2 times in this problem. So let me show you the process. The first thing to do is get your constants all on one side, because we know our radius is going to be a constant. So add 10 to both sides. So then we get an x squared minus 6x plus y squared plus 12y equals 36. And now we're going to complete the square with 2 sets of numbers. So I'd like to complete the square with the x values, and I'd like to complete the square with the y values. If your problem doesn't have the x's and the y's together, always kind of group them together and write it in standard form where the y squared is first and the single y is second. So now we need to calculate our special value for each one. So let's make room for it. So x squared minus 6x plus our number that completes the square plus y plus 12y plus our special number that completes that square. And then what we do to one side, we've got to do to the other. So that's going to be a 36 plus the first number and plus the second number. So what I add to this side, I also add to this side. So then let's do this. Negative 6 over 2 is 3. 3 squared is 9. So I add 9 to both sides. 12 over 2 is 6. 6 squared is 36. So we add 36 to both sides. And now we complete the square by turning this into a binomial squared. So the negative 3 times negative 3 is 9 and adds to negative 6. So x minus 3 squared. And then 12 over 2 is 6. 6 squared is 36. So y plus 6 squared. And then 36 plus 9 plus 36 is 81. So now we're ready to calculate our center and our radius. So our center lives at 3, negative 6. Remember, it's opposite of what's in the equation. And then this 81 is r squared, which means that our radius is 9, because 9 squared is 81. Thank you.